sklearn, kernel approximation, SkewedChi2Sampler. A detailed explanation. Purpose. The SkewedChi2Sampler class in scikit-learn's kernel approximation module is designed to approximate a nonlinear kernel by using a random Fourier feature RFF approach. Specifically, it approximates the chi-squared kernel, which is often used in applications involving histogram-based features. Why use kernel approximation? Computational efficiency. Kernel methods often involve calculating the kernel function for all pairs of data points, leading to high computational cost, especially for large datasets. Scalability. Kernel approximation methods like RFF allow you to efficiently approximate the kernel function using a smaller set of features, making the model more scalable. The chi-squared kernel. The chi-squared kernel is a popular choice for data that can be represented as histograms or frequency distributions. It measures the similarity between two histograms by considering the squared difference between their corresponding bins, normalized by the sum of the bins. Random Fourier features RFF. RFF is a technique used to approximate a kernel function by projecting the data into a high-dimensional space using a random linear transformation. The key idea is to utilize the Bochner's theorem, which states that any continuous, positive definite function like a kernel can be represented as the Fourier transform of a probability distribution. SkewedChi2Sampler implementation. The SkewedChi2Sampler class implements the RFF approach for the chi-squared kernel. It leverages the fact that the chi-squared kernel can be expressed as the Fourier transform of a gamma distribution. Key parameters. Gamma. This parameter controls the shape of the gamma distribution used for generating the random Fourier features. A higher value of gamma will lead to a wider distribution and potentially more accurate approximation, but also higher computational complexity. N components. This parameter specifies the number of random features to generate. Higher values will lead to a more accurate approximation but also increase the computational cost. Random state. This parameter allows you to set the seed for the random number generator, ensuring reproducibility of the results. Usage. You can use SkewedChi2Sampler in scikit-learn pipelines by including it as a transformer before your chosen model. This will transform your original features into a set of random Fourier features that can be used by your model. Example. Python. From sklearn, kernel approximation import SkewedChi2Sampler. From sklearn, linear model import logistic regression. From sklearn, pipeline import pipeline. Initialize the transformer. Transformer SkewedChi2Sampler gamma 10. N components 100. Create a pipeline. Pipeline. Sampler. Transformer. Model. Logistic regression. Train the pipeline on your data. Pipeline. FitXtrain. Y-train. Make predictions. YPRED pipeline. PredictXtest. Elaborated description of key values in YAML. While YAML is typically used for configuration files, you can still represent the key parameters of SkewedChi2Sampler in a YAML format. YAML. Parameters for SkewedChi2Sampler. Gamma 10 controls the shape of the gamma distribution. N components 100 number of random features to generate. Random state 42 seed for random number generator. Key points. SkewedChi2Sampler is a powerful tool for efficiently approximating the chi-squared kernel, which is commonly used for histogram-based data. RFF techniques allow you to use kernel methods in large-scale settings by replacing the kernel calculations with a linear transformation. Tuning the gamma and n components parameters is crucial for achieving the best balance between Accuracy and computational efficiency. Conclusion. The SkewedChi2Sampler class provides an effective way to approximate the chi-squared kernel using random Fourier features. By understanding its implementation and key parameters, you can use this tool to enhance the scalability and performance of your machine learning models, especially when working with data represented as histograms or frequency distributions.